interesting. So I'm going to give another minute or two. In the meantime, this is the URL for the repo. Git clone in your terminal or go in your browser, download the zip, extract it. And if you want to follow along, all the solutions are there. Copy of the slides are also there. And I just made this public a few hours ago, so if it doesn't work for some reason, just let me know and I'll address that. Good, yeah. All right, friends. So everyone get that? I will give another few minutes later for it as well. But with all that being said, let's get started. So the title for today's workshop, as you probably know, is Agentic AI for Threat Hunting. Just very quickly, who am I? My name is Fawn. I'm originally from South Africa, but I live in Quebec. I live in Val d'Aved, about an hour and a bit north of here. Uh, my main interests are really just kind of what I do for work. As boring as that is, so I'm into securing AI. I have a beautiful family, and I try to undo the long hours in front of a computer by different forms of exercise. I like going for forest runs with my dog. That's my favorite. I'm also an instructor at a company called Anti-Siphon. That's part of kind of like Black Hills family of companies. And I also work for another one of the companies called Active Countermeasures. But I resigned there last month because I'm starting my own thing. I'm not going to plug it now. That's a little bit shameless. I'll do it at the end. But if what I'm going to speak about is your jam and you want to learn more, then that's where you want to go. So I just want to do a real quick poll, and I'm sorry, I'm going to ask you to interact a little bit, but can you just stick up your hand if I say an agent and you know what that means, you feel fairly confident. All right, now keep your hands up. How many of you have used an agent? Claude Code, Codex, Cursor, right? How many of you use it every day? How many of you have gone beyond a stock code agent and maybe use something like open agents, deep agents, or downloaded the SDK from Anthropic or OpenAI and kind of hacked your own thing together? Okay, cool. Okay, great. So that's perfect. This talk is intended for all of you guys. You might get a little bit bored every now and then, but hopefully there's enough other stuff to keep you engaged. All right. So what's the goal of today? By the end of this workshop, I just want you to have a clear picture in your head when I say applied harness engineering for a threat hunting system. You wouldn't have been able to master it, but you'd know enough to have a conversation with somebody tonight when you guys go to the event. And you would know enough that if this is something that spoke to you on some level and you want to go and learn more, you'll know exactly where to go and what to learn. Okay, I'm going to give you a good map of the terrain, and we're going to dip our toes into some of the what I consider the most foundational aspects of it. Okay. So before we get into it, I just want to level set with you guys. The first thing is this is not a coding class, right? Code is obviously involved. We're going to be creating our own harness, our own agent, but I'm always going to be focusing on the higher layer of abstraction. So when I show my slides, I show diagrams. I'm going to be showing concepts and ideas. So even if you've never written a line of code, totally cool. You can 100% follow along. For those of you that are interested in the code that represents the ideas we discuss, well, I share the repo with you guys so you can go look at that, right? The next thing is all of this is essentially a distillation of a thing that I'm creating myself, but the thing that this is based on is itself still a work in progress. Okay, this isn't deployed commercially, it's not production ready. It is an amazing thing, and I wouldn't be asking you for your time to come here and learn from me if there aren't great aspects of it. But at the same time, it's just somewhat, you need to be somewhat grounded uh, in understanding that this isn't something that you'd want to roll out. You don't want to put a request in on Monday from your boss that you would now want to vibe code something like this together and replace CrowdStrike or something. Okay, it's very much still in the proof of concept terrain. And then the final thing is, though this is a work in progress, I've been doing this full time every day since December last year. And so it's way more than we can cover in 3 hours. 3 hours is a challenging amount because if it's 1 hour, I know I can just give you the high level overview. If it's 16 hours, I know we can go in some depth. With 3 hours, I want to give you the high level overview and I can show you some depth in some things, but I can't show you all the depth in all the things. I just wanted you to be aware of that. You will have an idea of what the entire system looks like. There's 7 components. I'll share everything, but we will meaningfully discuss 3 of the 7 components. All right. And if you wanted to learn more about the others, I'll make sure that you understand how to teach yourself or make resources available for that. All right. So hunting with agents. But actually, one thing I actually want to know, just out of curiosity, because I'm a little bit in a threat hunting bubble. Do all of you guys know what threat hunting is? What's meant by threat hunting? Like, put up your hand if you feel confident. Like, you either work in threat hunting or. Oh, okay. All right. Okay, cool. So when I say agentic threat hunting, there's 2 things that I imply by that, right? The one is building the system to hunt with agents. And then the second thing is actually hunting with agents, right? Making the tool and using the tool. I want to be very careful when I speak about agentic threat hunting, and even when I consider agentic, it's extremely buzzwordy and stuff right now, so I'm going to do my best to cut through all that. I'd never imply automated or autonomous threat hunting or security. Everything that I'm teaching in my kind of philosophy is how to extend the human hunter, how to scale your own expertise, and how to build systems to do that, right? At the same time, it is one of those cases where if you build the right system, because so much of it's going to be running on inference, doesn't take care of itself, but it largely takes care of itself, right? You still obviously need to know how to threat hunt, but you needed to know how to threat hunt to create it in the first place. And if you build it right, it's going to be, a lot of it's going to be taken care of itself in number 2. Again, it doesn't mean it's automated. It just means it's going to work. It works well enough so that number 2 takes care of itself, right? And so when I say create your own agentic system, what I'm really talking about now is, I don't know how many of you guys hang on online, but now kind of the buzzword du jour is harness engineering. It's kind of like the new thing, right? So harness engineering just means building a system for agents, right? That's all it really means. I'll get into some somewhat more technical definitions a bit later on. That's why I'm saying in the beginning when I said what is the goal for me is to understand what do I mean when I say applied harness engineering specifically for threat hunting. Before I jump into it, I just want to mention questions. Obviously, the great, beautiful thing of us being together here is that we can be interactive, and I want it to be as interactive as possible. So please feel free to ask questions. There are about 18 sections. They run about 5 to 10 minutes. So my only real request would be wait until I'm done with the section before asking a question. However, if you have a question that burns deep inside your loins like a flaming golden hawk, then interrupt me by all means and I'll get to it, right? There's no taboo on that. It's just to keep the rhythm good for everyone so that there's not this kind of janky stop-start the whole time, all right? Let's go. So harness engineering. So I just want to kind of like define the basic concepts a bit better before we get into it, all right? So what is an agent? Most of you know now what an agent is. You know, the classical definition, agent is basically LM stuck in a loop. It has a goal. It has access to tools. It has some guardrails. It'll self-evaluate. When it believes it has reached the goal, it'll exit the loop. I don't really care about that right now, although that is a correct definition. The definition I want to share with you right now is that an agent is a model and a harness, right? So when you think about something like Claude Code, right, there's essentially, if I'm going to simplify it, two components. There's maybe you're using Opus 4.6. That model is running somewhere on a cluster, right? You're shunting data to and fro in a JSON blob probably. It's performing inference. It's giving you data back. That's the model, right? What makes Claude Code different from running Claude in your browser is that it's an application. There's a code. There's, it got leaked a few weeks ago too, and we all saw it in all its glory. It's a TypeScript application, right? I think about maybe 500,000 odd lines of code or something like that. That's essentially the harness, okay? So what is the harness? If you're not the model, you're the harness. Every piece of code, configuration, execution logic that isn't the model itself. A raw model is not an agent. Just reinforcing what I said. This definition is from this guy. He works for LangChain. And if you're interested in this kind of stuff and harness engineering, then please give him a follow. I do want to mention that what I just shared, everyone won't agree with that. And that's not the only definition of an agent or harness there is. Here's somebody that says an agent is weights and context and harness. So they added context. And then this guy, who I also follow, I think is great, added a fourth component. So why don't people agree on this? It's because, guys, a year ago, if you mentioned harness engineering, probably nobody would even know what you were speaking about. There's no international consortium to define what is and what isn't a harness. It's a kind of fun and interesting thing to be involved in, as many things in InfoSec, because it's kind of like evolving in real time, and a lot of the conversation is happening on X, right? So somebody proposes an idea, and depending on the collective response, maybe that idea gains traction, very mimetic, right? Or it doesn't, okay? I just wanted to share that in case some of you, the definition doesn't sit with you guys. You have to understand that there's no kind of agreed upon, there's no central authority on this yet. So agent equals model plus harness. Let's accept that's true for the moment. And then if we ask ourselves, how can we optimize an agent? There's obviously two components to it, right? So the first question then might be is, well, we can optimize the model. Can you optimize the model? Well, you can choose which model to work with, right? And this is just kind of like very high level. There's obviously much more than this, but I think the primary bifurcation is what we call frontier models, right? The ones we're willing to pay for. Really Anthropic, OpenAI, Google kind of straggling around there too. And then some people consider XAI part of the conversation. I'm not too sure about that. And then obviously open weights too. And the classic idea is they're about 3 to 6 months behind the frontiers, right? So a lot of the Chinese labs have amazing models, Kimi or DeepSeek or Qwen. Right? So you can choose which model to use. If you choose, let's say Haiku, right? Claude Haiku, or you're choosing to use OpenAI GPT 5.5, the performance of the agent will differ. So there it's really about what are you willing to pay per token? Or if you want to run local inference, if you want to run open weight models, what are you willing to spend in hardware? To run a 400 billion parameter model locally, sorry about that. To run a 400 billion parameter model locally, you are going to have to spend quite a lot of money in hardware, right? Now, once you've chosen the model, you can't really do anything. Right? Model, weights, parameters, tokenizer, architecture, you can't really change any of those components. You're kind of stuck with what you have, right? So then the other way we can optimize it is via the harness. The good news is the harness is actually where most of the leverage is, right? It's about us creating all the scaffolding around what are the tools available, how does it orchestrate itself, what is context window management look like, everything beyond the actual token prediction. gets to be controlled by us. I don't want to say everything, obviously, like the context window size and everything, that's set by the model creators. You can't change that. But there is so much you can then control on top of the weights, right? So again, just to kind of reinforce this point, if you think about cursor or Claude Code or Codex, what makes it cursor, Claude Code, or Codex? It's the harness. It's the application. The application is the code running because, again, I can open a tab in my browser and get access to the same model as I do through Claude Code. Why don't they behave the same? That difference comes down to the harness. So the good news is not only is this where we have the most control, but it's also where almost all research shows the biggest impact exists. I'm not going to go down a research rabbit hole to prove a point to you guys. Here's one article also written by this guy. There are more studies and there's things on ArcSiv and stuff like that. If you wanted to, prove it to yourself, or wanted some more empirical evidence on that front. But the general consensus is the most power, your most leverage isn't anywhere in writing the harness. Okay. So now when I say harness, create your own harness, what are kind of the options available here? There's essentially 4 options. The first one is a stock harness. Again, Claude Code, Codex, Cursor, right? Fawn, you just said you create your own harness. You're not creating your own harness. You don't, right? You use a product, but there is a lot you can customize and control, in terms of your context project files, claude.md, in terms of your hooks, everything. There's a lot you can, and some people, and especially people that are more developers, they'll just stay in this realm because it's not really necessary to customize your own harness when a lot of smart people are already optimizing a harness for development work, right? I created 4 categories here. They're kind of contrived and artificial. And the reason being is that there isn't really 4 groups. I just want to create a conceptual roadmap so you have more or less understanding. Okay. So the second one is there are things like open agents and deep agents where the core fundamental architecture of the harness of the agent is given to you, but everything on top of that, you have to implement that. Okay. And then most of the labs, so Google, Anthropic, and OpenAI, as well as, I guess some of you have heard of LangChain or LangGraph, these are kind of SDKs, right? So what do I mean? It's, for any of you that have done any development work, it's just a library with the primitives that are available so that you don't have to write everything from scratch. And at the bottom, which is highlighted because that's what we're going to be doing today, is we're going to be kind of creating it from scratch. Most work, most control. At the same time, when it comes to things like hitting the model provider's API, we're not going to be coding that from scratch, obviously. We can still, we don't have to be dogmatic about it. We can selectively use some of the SDK, but when it comes to the agentic components, we're going to be creating that ourselves. Right? And that way, when you leave here, you have code that actually show you the patterns, and it's not all abstracted away into a library that other people already created. Still beckons the question, what is a harness, Fawn? What constitutes the harness? Well, I don't find it useful to say what a harness is constituted of, and the reason for that is it's really for me like if you had to say, hey, Fawn, what equipment do you use to play sports? Then I would say, are you talking about water polo or ice hockey or badminton, right? It depends what sport you want to play, what equipment you're going to use. It depends what harness you're going to create, what components it's going to have. So today we're talking about a harness for threat hunting. Okay. This is the end of this little section. So I'll just, are there any questions specifically about what I just discussed? No, all good. All right. Agentic hunting. So we're talking about creating agents, a harness for threat hunting. So I'm going to talk about a 7-part threat hunting harness. The 7 systems. I'm going to run through all of them now and give a high-level overview. It is, the point here isn't for me to share it to such a level of detail that you understand it. I just want to introduce you to the general terrain, and then you'll get to know them more as we dig into them. I kind of find it useful first to give you kind of a quick exposure, but again, If you feel a little bit lost, if you can't recall all of them right after this, it's not expected, all right? First part is distillation. Context engineering, tools, skills, orchestration, shared states, and feedback and evals. Let's chat about skills. How many of you have heard of skills? Skills.md, right? Okay, cool. So skills.md, the way I'm using it here has large overlap, but it's not completely congruent with a more popular idea, but it is a markdown file with YAML front matter, right, that contains some metadata. But really what skills always are is the formalization of tacit knowledge, right? So a lot of times, let's say in the threat hunting context, you might be hired by a company, you might go there, they have different processes, how they like to hunt, and the way it exists is kind of weirdly chaotic. They might have some documents, but you'll kind of get on the job and it exists in people's minds. And you'll kind of learn on the job the system, that threat hunting system. The idea about skills is to concretize that. Okay? This is one of the main ones we'll be spending much more time on as well. So we'll be going into this one in more depth. So I'm going to be showing you this diagram that I'm going to be building as we go along. But in my system, I have actually 7 different dimensions of skills. These aren't 7, but we're going to be covering 4. So these aren't 4 skills. These are 4 dimensions of skills. So each of these could be a particular skill. What I mean by initiation is how do you start a threat hunt, right? Is it because you receive new intel and there are new IOCs and you want that to trigger a new hunt? Or is it because you're looking at certain statistical indicators and one of them has crossed a threshold and you want to start a hunt? Those are 2 different skills, 2 different ways to start it. Right? Detection, what do you want to detect? Assessment adds more insight by looking at the finding in context, and narrative takes different skills and weaves them together. And again, I will cover all this in more depth. Orchestration is how do you have a team of agents working together? Right? If I'm just running in a serial way, ask a question, return, ask a question, return, that's kind of a very linear, I'm not parallelizing my work, right? Maybe sometimes I want one agent, but I want that agent to spawn sub-agents. Right? It has a meta question. It breaks that question down into 5 sub-questions, gets 5 agents to go investigate that, bring back what they find, and it synthesizes that finding, right? That's one form. You get maker checker, you get Magentic. There's a lot of different designs to serve different purposes. It's also something with a lot of power, and we have to be careful to not indulge because the temptation there is often to make it kind of as complex as you can make it because it kind of feels cool, right? But a lot, I think, on what I'll discuss today and what the field itself is reflecting on now is always keep things as complex as they need to be. Don't over-engineer, right? So I just showed you this. So for example, we might actually have an initiation, and this is called the fan out. It actually spawns 3 sub-agents that sequentially passes each of these to another agent. And then this is a fan in where a 4th agent yet will synthesize all 3 of those findings, right? Shared state. So shared state, when I have different agents, how do I make sure that what one agent learned or its summary is accessible to another agent? Right? It can be extremely simple. You can have a in-memory object, right? Like a struct or something like that. And if you think about it, the context window also like really serves this function. It's limited. Or depending on what you want to do, maybe you want to use something like a RAG, or maybe you want to use a database, or something that's very popular now for more complex use cases are knowledge graphs. Knowledge graph it's a very efficient way of capturing high density information and making it available to other agents. So I just drew this little thing just to show you. Imagine how we started and these 3 agents all learned something. And I imagine this is their output. And now that gets passed to these agents, so they have access to it. They all have their finding, which is that output. And then they pass it forward to the narrative agent that has access to everything and then has its outputs. Okay, shared state, just it's not transient, right? It can learn, it can gather information over time. Distillation is kind of the it's a in one way poor choice of words because distillation actually means something very particular in the world of agents. And this is kind of like my own concept. So this isn't at all what I mean when you distill a model. But distillation is when you take raw telemetry and you don't decrease the amount of telemetry, you summarize it by looking for certain patterns, and you don't replace telemetry, you overlay it. Right? I'm going to get into more detail with this, but one way you can think about it is one of the biggest challenges for agents is just imagine you give it 1,000,000 sysmon logs and you're like, go find something. Right? It's not like because it's AI, it can magically run through all 1,000,000 logs and find patterns. It doesn't work that way, right? You want to create some kind of map overlay on top of it to give it the ability to understand probabilistically what is the most likely place for me to go find threats. Okay. And what this looks like, I'll get into more detail. Like I said, this is actually the work and research I did at Active Countermeasures. This kind of grew out of that. That wasn't an agentic system, but this is a big interest of mine, even for manual threat hunting, because if we're just running detections as we kind of do in a response-based system, I don't. I think it's a poorly designed system to leverage what's called human intuition or reasoning, right? So in my distillation machine, and notice they're not connected yet, but we have raw telemetry. There's 4 intermediate forms, and then the last one that you're going to get acquainted with today is called post-enrichment candidates. So, tools. What agent can do, what it cannot do, how they can do it, what requires permission, right? I think most of you, if you have a sense of what an agent is, you know, one of the unique selling propositions, distinguishing characteristics of agents are tools. They can do stuff, okay? So in this case now, remember we had our telemetry, we have our kind of skill system, which is really like the heart of the detection engine, but it needs to access that telemetry. And one way you can do that is with tools. Sure, a lot of you have heard of MCPs. So MCP, kind of like a intermediary to access APIs, right? USB for great way of putting it. Thanks. I'll touch on that a little bit. Maybe some of you are aware as well. It's also one of those things when in the beginning it came out, everybody was like, "Oh my God, MCPs are amazing. MCP for everything." But now people are like, there's actually a pretty big context cost associated with it. The shell is Turing complete, right? MCPs are not, right? It's on Rails. So use MCP when it makes sense. Okay? Context engineering. It's all about optimizing inference time knowledge provision. Right? Models know things, but they don't know everything. Some things you want to tell them at runtime. What's the best way to do that? So here, for example, while this system is running, there's specific information we'd want to give this skill system, and there's specific information we want to give the distillation pipeline. One example might be threat intel. Right? It's processing the logs. It looks at the destination IP. We have access to a threat intel database. Why doesn't it just stamp on that immediately? In a deterministic sense, why would I ask my agent to go do a lookup of an IP address, and why wouldn't I use a simple line of code? Right? It's another, I think, very important meta principle. The kind of meme gag on this is you ask somebody like to write a function that creates, choose a random number between 1 and 100, and they do an API call to a model and ask it to return a number between 1 and 100. Don't be that guy, right? There's library functions for that. It'll do it better, cheaper. And then the final thing is feedback and evals. And feedback and evals is really all about how does the system improve itself over time? How do you create systems whereby the system can figure out how to improve itself with human oversight and guidance? And then evals is all about, let's say I got a suggestion on how to make my system better, and I made it better. And I'm like, my vibes are telling me this thing works better. It's not a great system, right? You want to have some kind of way to actually quantify that. So evals is all about quantifying that. So finally, imagine the system produced a report in the end, and then the human got it. So many ways in which this can happen. This is just one example. Goes into a feedback and eval system. The human would work with some of the suggestions, and this can improve any component of the overall system. And then again, evals measure, was there an improvement due to the changes? All right. Cool with all that? Yeah. Yeah. Yes. I it would be hard to think of any situation, especially when agents are involved, to not include an audit trail. Right? That's a kind of like I would say a primitive, something that is always implicitly designed into the system. Because again, guys, we've kind of been quote unquote gifted this weird alien technology. It has incredible powers, and it has terrible. It has very weird weaknesses as well, right? A lot of the design is about amplifying the strengths and minimizing the weaknesses. And one of the major weaknesses, is everyone here understand what I mean when I say it's non-deterministic, right? We all know what that means. Anyone not know what that means? Okay. Non-determinism. So for a precise security system, that's not great, right? And so one of the ways that we have to make sure, and just to deal with hallucinations and stuff as well, is that anything that can lead to an important decision or outcome, you have to verify that stuff, dude. Yeah. Cool. Great question. Thanks. All right. Let's jump into our first lab, everyone. So there's a little bit of a lecture, and then I'll run it. And again, if you want to follow along, please follow along. And if you don't want to, I'll be running it too, so you could see what's happening on the screen. All right. So imagine you are playing a video game. Everyone's here has played some video game, right? Zelda, something. So they kind of all have this pattern where you're the player and you have items and gold and XP, and then you would do different stages, right? Stage 1, stage 2, stage 3. Now imagine our player goes to stage 1, he finishes it, and then by the end of stage 1, the items, the gold, the XP is increased. Similarly, you play stage 2. Sorry about that. How rude. You play stage 2, and then items, gold, and XP increase. And then finally, you play stage 3. Similarly, everything increases. So the character is transitioning through stages, and in each stage, stuff happens. Right? There's a bundle of specific related events, and the character has a set of continuous properties, and we call this state. So the two words I want you to remember now are stage and state. Okay. So our workflow that we're going to build now is going to transition through 3 stages. And the application has a set of continuous properties state. Remember, I already shared state, and I said it's important. We don't want to be like the Christopher Nolan movie Memento, where the dude forgets everything all the time. We want to have the ability for the future agent to know what we found. Right. Don't overthink stage for me, please. Just think of it as something happened. That something could be a single function call, but it doesn't have to be. It's you get to design what a stage really looks like. It's just something happens. Later on, that's for us mostly going to mean there's a discrete API call that happens there. But it can be deterministic or non-deterministic. It could include an agent call, or it can just be a function call. And actually, for now, we're not even going to introduce agents into the picture yet. How do I minimize that? Oh, there we go. I just want to kind of lay the architectural blueprint with you guys, and then we're going to start introducing the model and turning it into more of a threat hunting system, right? But for now, I just want to kind of sketch the outline. How are we going to capture states? So it's going to be in memory, accumulating, and the core operative word here that you'll always hear that's very important is immutable. Okay. So we just have an object here. This is actually what we're going to build. It's just an object, right? These are 3 arrays. These are arrays of objects. So we can have different objects gathering there. We're just going to call them inputs, analysis, and summaries. By the way, what we are actually creating, what state really is a proto context window. If you were to work on your agent further and evolve it and do token count and introduce the ability to compact and all that, this is like the original light sensor was to eventually evolve into an eye, right? It's a proto context window. So just so you're aware of that. But I don't want to call it that because it lacks many of the kind of core characteristics of that. So right now we're just gonna have three functions. Each one, all they're gonna do is they're gonna append something to one of these arrays. Okay, so it goes through stage one. It basically, and by the way, this isn't an integer, it's not incrementing. I'm just telling you there is now one object in that array. Similarly, they're gonna add one object there. And similarly, you're gonna add one object there. Super simple, right? So I kind of put emphasis on the idea of immutability. What do I mean there? It's very important that you understand that stage one doesn't take stage zero and add something to it. It doesn't change stage zero. It duplicates stage zero and adds to it. Stage two duplicates stage one and adds to it. Why is that? Well, imagine at this state, I want to be able, I want to preserve audit trail essentially, right? I want to be able to, I'm sure some of you that have worked in Claude Code or Codex have seen that you can rewind to an earlier part in your conversation, right? Now, if I overwrote my context window, I can't go back in time because it's gone, right? If I mix two different liquids, I can't extract them from each other. Same idea. So one of the core design principles is you copy each time. There's a cost to that, obviously. It's got a greater memory cost, but it allows you to go back in time and also fork off nodes if you wanted to have multiple agents inherit the same state. All right, so does anyone not have the repo yet? Anyone that wants to take part doesn't have the repo? Okay, so there's the repo. Feel free to clone it. Sorry, the other thing that I forgot to mention is you will need Node and NPM, but NPM comes with Node. I'm not going to give you the instructions because it depends on, you know, if you're on Windows or Linux, do you use Chocolatey or do you want to use the MSI installer? But if you run node -- version and npm -- version, you'll see that just a way to confirm that you have it installed. All right. So should I give a couple of minutes for this? Does somebody want to do this real quick or is everyone good? Yeah, of course. You guys are free to take pictures. In that repo is the entire slide deck too in PDF. All right. So okay, so unless anybody objects, I'll move ahead. Right, let's run the lab. I do want to say that when you get the repo, you'll see inside there's lab 01 to 08. I didn't commit the modules, right? So every time you cd into it, and I'll remind you each time, first just run npm install so that you get the node modules, the dependencies, and then you can run npm run lab, okay? Oh, okay. So right now I can't change my window. Let's see what's going on. Ooh. My windows, yeah. I think it's because it's shared. Oh, wait. Sorry, I can just do this. Not a caveman, I can figure this out. All right. All right, so you guys can see there lab 1 to lab 8. So I'm just going to open lab 1 there. Actually, let's open my terminal. Like I said, if you go in there now, please run npm install first. Well, do npm run lab. Really, really not exciting, guys. Sorry, very dry. No agent call, no AI or anything fancy like that. But just to show you our memory object there, I can show you at each state we added something to the array. Here we're showing you immutability, showing you they're not the same. And just so you understand what those functions did, each of them basically created an object with 3 fields, 3 strings. It's the ID. It's giving us an audit trail showing what ID it was based on, and it's just adding a random observation. Okay. Right now, I just chose like random things to say about the weather, but we're going to replace that with our actual threat hunting system. Just placeholders. Right. So very simple. Anything unclear about that? Any questions about that? All right. All right. Straight into lab 2. Okay, so this is what we created now. Again, we're just adding deterministic input there. Let's actually introduce a model call. Okay, so see this little symbol, guys? I just chose that symbol. That means whenever I show that, that means there's a model call taking place at that stage. All right, that's all. So now stage 2, instead of just copying the same string to this object every single time, it's going to take the string from stage 1, right? It's going to send it to an LLM. It's going to ask it for a specific insight based on the text it sent it. And it's going to capture the return text, and it's going to save that inside of the object. Okay. So prompt, model call, capture the result, and append it there, right? Does everyone here know the difference between a user prompt and a system prompt? Put up your hand if you don't know the difference. Okay, one person. So when you go and let's say you open up OpenAI or ChatGPT in your browser tab and you ask a question, right? What is the capital of France? That is essentially the user prompt. That's the question you're asking it. But what you have to understand is when it arrives at the model, there is actually a lot of extra text that's added to that. Things like guardrails, things like if they asked you to hack the Pentagon, don't do it, ChatGPT, things like that, right? That is the system prompt. It's everything that the creator of the harness adds on top. But we're the creator of the harness now. So we create the user prompt, which is the input, and which is typically like the specific requests. And we're creating the system prompt. And in this case, the system prompt is more like the instructions, right? So we can see this is actually what it is. You are a precise analyst, not an analyst, a precise analyst. Very important. It's not important at all. I'm just kidding. Explain the observation in one sentence. This is kind of like giving instructions, right? The user prompt is analyze this observation, and that's input value. That's just taken from that, right? So whatever stage 1 added there, it's going to take that and it's going to send that to the model. How can we speak to models? Kind of spoke about this a little bit earlier, but I'm just going to give you kind of the main overview. You can use a remote API. The examples I gave there are all frontier models, but you can also have access to open source models online. Right? You can use something like Grok, not the Elon Musk Grok, but the one that ends in a Q. So lots of other services. I think maybe CoreWeave does that as well. But if you want to run a 400 billion open source model and you don't have the hardware locally, which a few of us do, you can still rent compute online to run that. Okay. Give you a local runtime, we've spoken about that. And then I also mentioned at the start, some of you weren't here, but what I'm going to be doing is I already pay for Codex. So I'm just going to wrap Codex with this application. I'm going to spawn a sub-process, and I'm going to be using pipes to shunt data to and fro. Why am I doing that? I'm already paying for Codex. Why would I want to have extra API costs, right? So for any of you that have Claude Code or Codex on your host, I'll show you how to do that. And you can just leverage the fact that you already have that. If you don't have that, and you have an API account already, an API key for using any of the other frontier models or open source, you can use that. Otherwise, like I said, I'll share some screen slides. You can get a free account with Google. You can use Flash 2.5. That's totally free, okay? Just one thing that's a little bit, I guess, somewhat software engineering design is we don't want to like we don't want to tightly couple design, right? What do I mean by that is, let's say I decide today I want to use OpenAI. I don't want to like integrate the OpenAI API calls in my code, because what if I want to use something different tomorrow? Then I have to go change that. That's not a modular design. It's not extensible and it's not maintainable. So one way we can deal with this is with an interface. Does everyone here know what an interface is in software design? Yeah. Just think of it as a universal adapter, okay? Instead of saying here what I use, I just put the interface here, and I have all of these as separate files, and I just call that file. But if I want to change to a different file, I don't change my code in my application. I just change whatever file I'm using, all right? Does anyone here want to quickly take a few minutes and get a free Google API key and would like to follow along? Yeah? Okay, cool. So if you go to, what was the URL? aistudio.google.com. On the left here, you'll see dashboard, and you click on that, and you'll see API keys there. And then you just say, click create API key. Here I blanked out mine, but you'll just hit the copy button, right? And just save it somewhere there. So we'll just give like a minute for those that want to do that. All right. Let's slowly move on. If at any point I'm going too fast, you'd like me to pause, you want to catch up, just let me know, okay? So you're going to get the API key, save it somewhere. We're going to go into NorthSec Lab 2. You're going to run npm install, and then the next thing is run cp.env.example and make a copy of that .env. That's the environmental variable file. That's where you're going to save your API key as well as the choice of the model you want to use, all right? Everyone good with that? All right, so if you open up .env, this is what you'll see. And you can see here at the top, choose the model you want to use, right? So Gemini, Anthropic, OpenAI, or Codex, CLI, or Claude Code, right? And then here, depending on what model you want to use, you can just comment and uncomment the model you want to use, right? But that's how you're not going to tell your application what is the specific model you're going to want to use. Like I said, I'm going to be using Codex, right? I just wrapped Codex. Right, let's run our lab. Yes. Yeah. Great question. You absolutely can. And, you know, part of teaching a course is, I would say, like unveiling progressive degrees of sophistication, right? But when you get there eventually, absolutely want to do that. And I would say one big part of optimization is choosing the right model for the right job. If it's a very simple job, like one way you could roll this out in production would definitely be to have the menial work be done by maybe even an 8 billion local parameter model, which is free and which you can run on like 32 gigs or 64 gigs of unified RAM, right, on an Apple machine. But then when you have, let's say, higher in the hierarchy, the one interpreting its work, then you want to use a more sophisticated model. So yeah. So never think of when you create a harness, you don't have to be, it's not a monogamous relationship, guys. You can be a polycule and, get all orgiastic up in there. Use what model you want, when you want, for whatever role. All right. So I'm going to run it now. And one thing I want you to pay attention to is a bit of a design flaw, because again, this is a very simple harness, but I'm not streaming, right? So what does that mean? Usually when you ask Claude Code a question, it's going to take a while, but then you start seeing the text kind of appear in real time. My application doesn't do that. So we're going to call, we're going to wait for it to finish. Once the buffer is full, it's going to eject the buffer and we'll see the whole thing. So just so you guys do know, when we ask questions, and the more complex it gets, the more we're going to wait. So this is a prime opportunity to ask a question or to tell a joke. You want to tell a joke to the crowd? Just let me know. Lighten the mood. Okay, so remember we had a deterministic string and we sent it to stage 2. I'm going to run in the meantime while I explain to you guys. And then all that happened was, remember we asked our precise analyst, hey, can you interpret this and comment on it? So that's all that happened. The LLM received that first string and it just returned that. Right? Why did I run it again? I just want to show you guys non-determinism. We can see that the message is kind of the same, right? But it's not exactly the same. And that's non-determinism. Probabilistically, you're probably never going to get the same answer twice. The word or the insight or whatever is going to change every single time. This is depending on how you think about it, either one of the weaknesses or one of the strengths of models. Right? Any questions about that? Everyone has a good mental map of where we are, what we've done. All right. No stupid questions. Hashtag. Yes, you always want to run npm install first, because when I created it, it creates the node modules, the dependencies, but I didn't commit that. So you have to always run npm install first, so that npm is then going to download all the dependencies for you. Okay. For every lab, you got to do that. Sorry, that's a little bit of a hack. Oh, and that actually reminds me, I'll just give a quick minute, but if you now filled in your details, if you copied the ENV example in lab 2 and filled in your details, I don't want you to manually copy it for every single lab. So for Mac OS or Linux or Windows CMD down below, you can just run this command and recursively copy it into every single lab. Does anyone want a quick minute to do that, or y'all good? Yeah. Yes. So right here, at the bottom, you have to, so I ship with env example, which is kind of the template. So you create your env file. The application will actually use env. So when you open env, you'll see this. At the top, if you're going to use Anthropic API, write Anthropic. If you're going to use Claude Code, just write Claude Code. Should be Claude underscore code. Dash. Okay. Thanks, bro. Perfect. So you already trouble. Thanks, bro. Awesome. Flanked here by some awesome troubleshooting genius. Yeah, you have to uncomment everything else. Thanks. Uncomment everything. Uncomment the things you're not using. Yeah. Just keep this up another minute. Show me your hand if you want me to stay on the slide a little bit longer. Okay, moving on. Distillation. So we've now essentially just created a little foundation, state and stage, right? And we've now added a model core. But do you remember the 7 systems I showed you in the beginning that makes this a threat hunting harness? We haven't started with that yet. So this is now the first thing. Why do we start with this? Well, this deals with your input. Your input is typically raw telemetry, right? So I consider this part of the agentic system, but everything, the distillation process itself is actually purely deterministic. Okay. So what we just did was kind of create 3 stages. Later we'll add a 4th one. So we created the blueprints of this, and now we're essentially going to add this part. All right. So one of the central challenges of all defensive security, right, whether it's alert-based or threat hunting, is always dealing with the scale of telemetry, right? You can always hear some examples of a brand new Windows system domain controller going online and the amount of Windows event IDs. And if you don't tune it properly, sysmon and network connections, it's a massive, massive scale issue, right? And the kind of danger is to now think that, oh, well, the fact that I have this LLM muscle available just means I can just deal with it that way. I'll just point the agents, they'll process it. I don't have to worry about that. But dealing with this scale it doesn't go away with agents, right? There's a few things. A lot of you know what the context window is. Imagine I pointed to so many events that it just immediately fills up and compacts its context window before it actually gets to any form of analysis, right? But even if, let's say even you put a guardrail on to ensure that the context window is never filled up, there is a real point of diminishing returns when there's too much information in the agent's context window. Right? Have any of you heard of what's sometimes called as the dumb zone? The dumb zone, okay. Sometimes people call it lost in the middle, or I like the word context rot, just because it's like very evocative and stuff. Right? So what I mean by that is, even if, let's say you have a context window of 200,000 tokens, even if you can technically put 180,000 tokens worth of information in that, you will get poorer results than if you put, let's say, 80,000 tokens worth of results in. Most people consider the inflection points between 40 to 60% of the context window to be a point where the more information you add, the worse performance gets. Nobody really fully understands this, why this is the case. The way we can kind of anthropomorphize it is by saying, oh, the AI has, the LLM has too many things it needs to keep in its attention and do its focus, so it can't focus. It's obviously like a human way of relating to it. Definitely a lot of smart engineers at all the frontier labs trying to figure this out. In the meantime, we have to design around the fact that just because you can give an agent information doesn't mean you should do it. You only give an agent the info that it should have, right? One of the solutions, of course, is to break the problem up. You can say, well, fine, instead of having one agent look at 1,000,000 logs, I'll just have 100,000 agents each look at 10 logs. That kind of works, but patterns spread themselves over telemetry. That's the one part. And you get what's called siloed insights. So now you got to figure out how to get all the little mini insights together. It introduces another problem, right? Yes. So everyone here has a pretty good idea of what a context window is, right? It's kind of like what sometimes called the short-term memory, right? Now, part of you can think of a model as having 3 basic components, right? It's the parameters, the weights, the tokenizer, and the architecture. Part of the design is the context window size. For a long time, most models had about, I don't know if it was 200 or 250, but I know with Opus 4.6, for example, they introduced the million, and now with GPT 5.5 and things, we have 1,000,000 too. But the architecture itself cannot go above that. If I wrote a message of more than 1 million tokens and just sent it, I would get an API error. The model literally wouldn't process that. So when they create something like Claude Code, in order for it not to error every time, there's a process where essentially, before it gets to that point, it's going to take, let's say it's at 900,000 tokens. So it says, okay, before I get to 100 million tokens and before I hit that API error, I'm going to do an API call. I'm going to simplify it a bit, but this is the basic idea. I'm going to do an API call and I'm going to ask a model, hey, can you take this 900,000 and summarize it for me in 100,000? It's actually going to keep the beginning of the conversation, the end of the conversation. It just really summarizes the middle part. But essentially, it wants to summarize that, and then it restarts a new context window. So there's a fresh context window, but at least it got the summary of the old context window. Okay. That makes sense? Cool. So distillation, the concept is very simple. Instead of telling an agent, hey, go look at raw telemetry directly and find the threats, we basically overlay a map on top of the telemetry that is a prioritization map. Right? So I don't want to get too much lost in concepts, so I'll just give you guys one example, and this is related to what we're doing here today. Right? Imagine I'm looking for C2 beaconing, right? I'm looking for a specific connection of outbound patterns to a destination IP. That might manifest as sysmont event ID 3 or let's say zconlog, right? And let's say it's 1,000 distinct events, right? But with some very basic statistics, I can actually go and find those connections, and I can see whether or not there is kind of a delay and jitter histogram associated there, right? That's all pre-processing. So think of that basic statistics I did in terms of C2 beaconing as the distillation map overlay. Instead of having my agent go and look and do statistics, which it isn't really good at either. Well, it'll write a Python script to do statistics probably. Why don't I just do all the statistics beforehand, use it as a map overlay on top of my raw telemetry, and then it looks at that. I'm not making a judgment. I'm not saying there is C2 beaconing. What I'm saying is, here are probably the most likely candidates for C2 beaconing, right? So it turns the overwhelming log, 1 million, 10 million events that all look the same, have no value. There's no climb. And at least it gives it some shape so that it can understand what is the most likely ROI, bang for my buck. If I'm going to spend tokens and time and inference, what is the most likely place there probably is the threats, right? Very important thing to understand, it's not reducing or removing telemetry. The telemetry is still there and the agent can still access if it wants to find a specific field value in a specific event, it can still do that. It just doesn't look at that as its primary entry point. Okay, that's it. So before we get into the lab, I just want to show you what it kind of looks like inside of one, just so you have a little bit more grounded sense of what I'm speaking about. So again, the example I'm going to give is a beacon candidate. I've kind of just broken it into 4 parts because it's a giant JSON blob. I'm not going to put it on one slide. It doesn't really have 4 parts. I just created this so we can show it over 4 slides, really. So first is identity and scope. You can just see is the candidate ID that I've generated for traceability, the type of candidate, 3 tuple, right? What was the first connection, what was the last connection? And here you can see, these are derived from zcon.log, by the way, but here you can see it's 361 different connections that constitutes this C2 beacon candidate. Okay. Time span, 6 hours. Scored measurements, this is all the statistics I spoke about. So everything, if we look at connections and subsequent timing between connections, there's a way that even when you add jitter and things like that using a C2 framework, it typically does not look like stochastic human browsing, right? The thing it most resembles would probably be a background service, something like time or weather updates, but they tend to be much less frequent than a typical C2 connection, right? So again, this was all statistics. This is my value map overlay. This is what I'm putting on top of the telemetry so that the agent has different things to look at and compare. Attribution. So Zeek con.log gives me all the information. There's a 3 tuple. I can correlate that to sysmont event ID 3, which is the sysmont network connection. That gives me a GUID, which I can then correlate to sysmont event ID 1, meaning I can correlate sysmont event ID 1 to Zeek con.log. Why is that cool? Because now I not only answer questions related to the network connection and its behavioral characteristics, but also to the process that is mediating that connection, right? I do like network behavioral. It's also just kind of a fate of circumstance that that's what my mentor was into and what I learned. It gives you a very good hype overview, but you struggle to answer questions with definity because you need, the saying is network for breadth and endpoint for depth, right? You always want to correlate the network connection to the actual behavior on the endpoint, in this case, the process. So I've pre-processed that. It's very easy to do deterministically and add it into the same candidate. Why not? Finally, here is just enrichment. It's things I look about, like how many of the connections happen during business hours, is it on an Intel list, etc. And then here would be the original IDs of all 361 connections, right? Our audit trail, right? Okay, so before we get into the lab, any questions about distillation? Yeah, please don't apologize. That's a very good question. The honest answer is, remember in level set, I think my second level is, this is still proof of concept, work in progress. That's a question that would get to later on. It's not necessarily a primary design question for me. First, I need to show that it can detect everything it seeks out to detect before I can handle attacks against it. But that is obviously, as many of you know, within the world of using models, prompt injection is kind of the one major problem. We have a lot of different attacks. They all kind of boil down to prompt injections. And I don't know a lot about this, but from what I know about people, everybody that's kind of a somebody important in the field essentially says that based on the current systems and architecture, it's a kind of unsolvable problem, right? It can't fundamentally be solved. Yeah, so that's a good question. Thanks. But that's unfortunate answer. All right. Yes. Yes, they're all, so you'll take all the telemetry, you'll produce candidates, and they all have a value associated with them, right? And so you can, for example, then when you start your skill system, your agent, you can say, you can set a minimum threshold. If it didn't score 0.85 for beaconing, you can ignore it completely. And then from those that are left, do your triage by starting with the highest scored one. And then next one, next one, next one. Yeah. This is a thing that I've created myself. Yeah. I haven't decided whether or not to make it available per se, but if you are interested, it's largely based on an open source project called Rita, right? Which is written in Golang. And if you are a semi-decent vibe coder, what I could tell you is, or you could use Rita directly, or you could just point the agent to the logic. It's open source, it's on GitHub, and recreate it in whatever language you want. Yeah. All right. So there's still data for now. I'm just going to deactivate stage 3. We're also going to rename these. These function names were really just right at the start because we did something deterministically. But now we're going to do something a little bit more complicated. There'll be a few steps at each. So stage 1 is load candidate, and stage 2 is interpret candidate. So if you can remember before, we just had this kind of like made up string about the weather that was injected here. But now what I'm rather going to do is I'm going to load the top scoring beacon from data candidates enriched. So in the repo, you'll see now from lab 3 onwards, you will have the output of, you'll see what the shape of candidates look like. And they are, I don't know how many in total. I think there are 5 or 6 in there. In my own collection, I have about 24, 12 that I feel really solid about, that I've kind of stress tested, and then another 12 that are kind of works in progress. So the big difference here now, guys, is instead of, again, some made up string about weather, we're actually going to go grab a candidate from our JSON and then interpret that. And stage 2 is staying the same. We are adjusting the user and the system prompt a bit, which I'll show you in a bit. But we're not sending observation about the weather anymore. We're now sending a candidate. And so the user prompt and the system prompt now becomes, you are a security analyst. You will be shown one score beacon candidate produced by deterministic distillation pipeline. Produce a concise interpretation in plain English. What is this candidate claiming? What makes it notable? And what would make you look, what would you want to look into next? 3 to 5 sentences. And then the user prompt is essentially just injecting the candidates, right? npm run lab. Can I, would somebody mind getting me a cup of water? If I may be so bold. You would? Thanks a lot. Just starting to get parched throat. Let's do it. All right, guys. Yes. You get it from the data, but you need to perform statistical analysis on it. Yeah. Now it's one of those parts that unfortunately, because it's not necessarily AI, I couldn't nerd out on that too hard, in this specific course, unfortunately. I do a 8-hour version of this course, which I'll share with you at the end. If you wanted to learn more about that there, you can do that. Or like I told the gentleman behind you, the beacon specifically is largely adapted from Rita. They've already done a lot of the heavy lifting there. Thanks, man. All right, just remember, if you're doing this, to first run npm install, but then you can run npm run lab. Let's go. Is that Jeopardy? Yeah. Are you running with your local model? Yeah. How's it working for you? Okay. All right, maybe I'll just increase the size here. But here you guys can already see, and also just, I already showed you what's inside of the beacon. Remember, I didn't say this is a beacon or anything. I just gave it some basic statistical information, right? And now we're relying on the prowess of GPT 5.5 here and seeing, can it actually interpret this as a threat? Because again, I didn't say this is a threat. There was no value judgment on my part. There was just basic statistics. And it's saying the candidate is claiming that SVC host health.exe. Wow. Pretty suspicious, right? It's running from app data local temp, likely establishing a beacon to this IP, about once per minute for roughly 6 hours. What makes it notable is the combination of regular timing, so that comes from the statistics, PowerShell parent process, so PowerShell launching SVC host health.exe inside of temp, right? Pretty red flaggy. And a positive threat intel match, all of which fit common C2 behavior. The attribution is only partial because of the multi-process matching. So I would verify the exact process lineage and confirm whether this executable owned all the network sessions. Next, I would put the PowerShell command line, inspect the file and disk and its persistence mechanisms. If you can remember, we actually asked it for suggested next steps, right? And review other hosts. These are all great steps. I mean, I'm like, the first time I did this, I was already super impressed with what it could tell just from that candidate behavior. Yeah. Yes. Okay. Yeah. They have personalities too, right? I do find like Claude's models, I like interacting with them much more than Codex, but I've kind of switched over to Codex because it just produces less bugs, basically. Anyone else run a different, unusual model that has an interesting finding compared to this? No? Yeah. When we take a break again, let us know if it was able to do such a kind of detailed interpretation of the candidate for lab 3. Be really interested to know. Okay, I don't know what's going on with keynotes here. Bruh. I didn't necessarily plan a break. It's pretty full on, but if you guys get to a point where you feel like saturated and you want 5 minutes to stretch your legs and walk around, just let me know, okay? I also don't want to let it feel like a torture session per se. It's not my intention. All right, context engineering. So this was the definition I shared with you earlier, optimizing inference time knowledge provision. The way we could also kind of put it is it's about delivering the right knowledge in the right format at the right time. I don't know why I switched into an Irish accent there, at the right time. But now your question might be, but Fawn, LLMs, they're so wise, they know so much stuff. Why do we need to provision it with knowledge? So where does LLM's knowledge come from? It's kind of like, broadly speaking, 3 processes, right? Pre-training, gradient descent, right? All that next token prediction goes through, burns through megawatts, a lot of money. And then there's supervised fine training. And then there's reinforcement learning with human feedback. So 3 processes, sometimes called pre-training, mid-training, and post-training, right? But at the end of the day, guys, isn't it kind of whack that we spend $1 billion and do this process and you get like a flat file with a bunch of numbers in the end and you can speak to it and know stuff? That is like, I really think if I Rumpelstiltskin, was he the guy Rumpelstiltskin that slept for a long time? The fable? Huh? No, the guy who slept. No, Rip Van Winkle. If I was Rip Van Winkle and I woke up today and I saw this, I would be like, this is really wild, right? But in any case, I don't want to get too woo-woo here, but all the knowledge is in the weights, right? So we know that the weights know a lot. We just saw it interpret a beacon cannon. That was pretty cool. But there are 3 main issues. The first is the cutoff dates, right? The training is outdated. You know, a couple of months ago, they stopped gradient descent. They did a few other things. And then by the time the model is released to you, it's outdated. A lot of the time, it doesn't matter that much. Sometimes in this field, you know, when I ask it, I'll ask it for, I asked it last week about, for example, a Droid, which is a new open source coding agent. Didn't really know much about it. And then I went and I saw like, oh, Droid only really became popular like 3 months ago. So that's why. But in the context of threat hunting, this isn't always that important. More important is sometimes there's information it was trained on, but it's not 100% accurate, and you need it to be 100% accurate. A very good example of this would be your telemetry schemas, right? How many fields do your different logs have, and what are the names of those logs? Now, it was trained on Sysmon, and 99% of the time, it'll get the fields right. But is 99% good enough? I'm okay with 1 out of every 100 times it just hallucinating and breaking my system? Obviously not, right? So whenever it really matters, we can call this idea grounding in truth. We inject the schemas and tell it, like, put that in your context, dude, and compare it. Don't rely on the weights. Okay, this matters. And maybe the most important is, and this is, and I say this is maybe the most important. I watched an interview with a dude named Damien Luca. He's started a startup called Nebulock, which is kind of like the biggest agentic threat hunting startup right now. If we really think about what the major advantage of agents versus signatures and deterministic code is its ability to reason within context, right? It doesn't just apply a filter, a signature, but it can look at things and understand, maybe based on recent telemetry, what other APTs have been targeting our industry. It can look at, for example, a PowerShell command ran on, sorry, this is a very cliche example, but it's a good one. If a PowerShell command ran on a network admin's system versus Jane from accounting, obviously more sus on Jane from accounting, right? We don't necessarily expect, but maybe she's hardcore into her PowerShell, but in general. So anyway, all I want to say is you want to also furnish your model with information about what does your network look like, what are the hosts, what are the host names, what is the history. None of that is in the training because that's all personal. That's personal to your organization, all right? So the 6 context layers, I'm not going to go through these. I wanted to share it so it's in the slides so you can think about all the different things you might want to think about provisioning at inference time. Okay. There's also a lot of different ways that you can provide it. Some of you probably work with Claude Code, and you have Claude.md, right? So there's a good example of something that's going to automatically be loaded when you start the process. We have skills. Skills typically have got the YAML front matter that'll be automatically loaded, but the markdown body, only when the agent thinks it needs it, will it retrieve it. You can use a database, you can use Redis, you can use RAGs. Does everyone have a more or less an idea about what RAG is? RAG is really about being able to save information, but have semantic search, right? So a lot of times when we're searching for things, we want to look for precise keywords. But how models really work is with ideas, right? So if I say, can you find something related to a process injection attack from last week? I might not use the exact words that are in the database, but it interprets my meaning and can find what I'm looking for, right? So for the purposes of this talk, really what I want you to understand is, for me, the primary bifurcation is understanding the difference between injecting information and requesting information. So injecting is we literally take the information, we put it in the prompt, and we send that to the agent. And the thing is that will obviously 100% guarantee that the agent, the model, will receive it, but it's got a fixed token overhead. And I already, not only does it have a token overhead, which are costs, but I already told you guys about context rot. It's also sometimes called progressive disclosure. Only tell the agent what it needs to know at each step. Never think like the more, the better. The more, definitely not the better, right? So you only inject when you think in this call, the agent has to know this information. Otherwise, request, you can tell the model, hey, if during your reasoning process, you decide you want to read the intel, here's the intel. If you want to read the organizational context, here's the organizational context. Here are the things, and I'll leave it up to you to decide during your reasoning process whether you want to go and access that or not. More flexible, no fixed overhead, but what if we feel, again, let's think of the Sysmon schema concept. What if it'll break if they don't use it? Then we obviously would rather take the context overhead hit and inject it. Right. All right. So next lab, any questions about context engineering? The next time you say stupid question, I'm going to send you outside for 5 minutes. I would say it really depends on the design of the system, and I would have to understand architecturally more exactly what you're meaning and at what points, right? Yeah, yeah. Let's chat about it more for sure. Thanks. All right, so I'm gonna do lab 4. Remember, if you cd into it, if you want to run npm install first, right? Here, sorry. I didn't explain to you guys at all what we're gonna do in this lab, so let me do that first. So please remember that we had our 2 stages, right? We took our candidate and we now sent it to stage 1 and we said, hey, stage 1, can you interpret this candidate for me? And now we're actually want another interpretation of that data with organizational context. So I created a little file and you'll see it. It's called organizational context. And it just talks about the network, what are the different IPs, what are the different hosts, who's got what role in the company and all of that, right? So just one thing that you guys should know, I'm going to remove state, and it's not because it's not there. I think you guys get the point now, and I need the real estate to explain some other things. So I'm just going to erase that, but it's still there, obviously. So let's add stage 3 again. So just so you recall, stage 2 got the candidates like, yo, expert, can you please analyze this for me? We got the detection, the finding back, right? And now at stage 3, we're going to send that finding, the output from stage 2. And we're also going to give it organizational context. And we're going to say, hey, can you interpret this with the context of this? So you can see right here, I'm going to, would you guys say this is a good candidate for injection or request? That's a question. At this point, when I ask here, do you think I want to inject the organizational context, or do I want to tell the agent it can go and fetch it if it wanted to? We got a request here. Inject. Okay. We're a stalemate. I need a third person to break the deadlock there. Inject. No, that's... no, I need a fifth one. Go on. Request. Okay, you guys are wrong. It's inject, right? Because I want to interpret with the organizational context. So obviously, it's kind of a non-negotiable at this point. But thanks for playing. Yes. Mm. Yeah. So you'd probably have, so this is also, this is the assessment skill, if you remember in the beginning, and I said this isn't a specific skill, this is a dimension of skills. So you would have a different you'd have different skills there that would all only handle a chunk. So just look at one specific aspect, right? That's why I like to teach harness engineering. Those are the kind of constraints you can customize to your organization that you can't when you use a stock agent. That's the only way you're going to get that control. And defense and threat hunting is highly personal, right? It might even be that for like accounting versus marketing versus the devs, the scale is way different and you want to do it different for each of them too, right? So our system prompt, so now it basically says use the provide context to determine business meaning, severity, escalation rationale, response priority, and uncertainty boundaries. And our user prompt is basically just, this is the organizational context we injected there. And then here are the results from stage 2. And we're actually also passing the beacon here to it as well. So it's kind of seeing the entire chain. All right, let's run the lab. And of course, the good thing this time is I already ran it, so we don't have to wait. You can see here now the output. This is the first output, the detection analysis. This is the same one we got from the previous lab. It's just formatted differently. Why is it formatted differently? Because I actually even forgot to tell you. But another thing we added here is how to format the output. That is another thing you get to control. right? So not only organizational context, these I'd probably split up, for example, in two different skills, maybe. No, I wouldn't. Sorry, because you'd always want it formatted your way. But for example, imagine you like it a certain way, but your colleague likes it another way. Then they can just customize this. Right. And we can see then below this is our new. This is the assessment analyst. I'm not going to go through everything, but you can see now, for example, it knows the IP belongs to this host. It knows that it is a highly critical workstation used by a senior developer who supports finance, automation, and PCI adjacent. That's something detection couldn't really give me, right? The agent is able to look at a threat and assess its severity in lieu of the organizational context. And that's something within a threat hunting paradigm you typically need a human for. Yes. Mm-hmm. Yeah. So the question is, he just likes some clarity about what is the kind of the question we need to ask ourselves when we want to inject versus request, right? So the simplest, the one question you have to ask yourself really is, does it have to have this information? Like, is it absolutely required? If it's absolutely required, you inject, because injecting just means I copy and paste it in the prompt, and 100% the model is going to get that information because I've deterministically assured, right? So it's kind of like you have to do this. Request is like, here are a bunch of things available to you. And if you feel like you want to use one of these things, if you feel like it'll be helpful, go ahead and do that. These are options that are being made available to you. Okay? That helps? Yeah. So I guess you're asking, why don't you just always inject? Yeah. So the main thing is that you, if it's not necessary for it to have that information, then you don't want to inject, because injection has a cost. The cost is the token overhead, right? It's going in the context window. And if it didn't need that information, you are potentially reducing the quality of the feedback you're going to get and the interaction you're going to get with the agent by injecting it, because you're giving it, this is context rot, right? The dumb zone. It's like you are giving it another thing to disperse its attention on, basically. Yeah. That's good. Awesome, man. No, I'm sure. That's why I wrap Codex and Cloud Code. Any other questions, guys? All right. So can you guys basically see now we have two dimensions? We sent a candidate, we asked it to interpret it, did a pretty good job. But now we went a step further. We went to another API call. We gave the output from that and we said, hey, here's some organizational context and here's how I like to receive my reports. Give me deeper insights. All right. Cool. I think that's pretty cool, guys. Anyone else think that's pretty cool? Cool. Más o menos. All right. Two. So our agent is not much more specialized, right? It gets specific security information from our distillation process. It uses the LM to interpret that, and then we inject specific organizational context at runtime. But our agent, in fact, we shouldn't even call it an agent, because the agent actually is able to do stuff. Our harness, it can receive text and it produce text, but it can't yet do anything, right? So without tools, you just have a chatbot, really, right? You don't really have an agent yet. Important thing I want you to understand, that tool is nothing specific. It is any bounded capability that you expose to the agent. The word choice here, exposed to the agent, is very intentional, and I'm going to dig deeper into that. I really want you guys to understand what it means when an agent uses a tool, okay? But just so we know, it can obviously take many different forms. You can have a function. And for those of you that have a bit of a development background, you know, if whatever library you use, you can you can do a lot, right? There are a lot of functions you can use and do a lot. Anything, if you want to write in Python or TypeScript, anything that you basically program in, your agent can do that potentially, right? And by the way, do you guys have a sense why Python and TypeScript are the kind of two predominant languages for harnesses right now? Anybody know that? So it's kind of just the inheritance. If you guys know the kind of culturally from the machine learning world, they were all Pythonistas, and then from the web app world, they were all JavaScript, and then TypeScript became like cool JavaScript, right? So it's just inheriting it from two different cultures, and you could write it in anything you want to, of course. But if you're going to do if you want to do the API calls, then they're often just available in a few sets of languages. But I think, for example, Anthropic makes them available in Go, and maybe Rust and stuff like that too. So you don't have to use that. HTTP request use an API, an SDK call, which again is just really a library that you get from the agent developers, right? Or an MCP server. But here's the big thing. Models can't just use tools, right? The ability isn't imbued in the weights. Think about it again. A model, Opus 4.6 is a bunch of parameters and a tokenizer. It's running on a cluster somewhere else. How is it sending requests to my operating system API? How is it making tools run? It's not even on my host. How's that happen? Yeah? MCP is a way to use, it's a specific path to use APIs. Yeah. I can get into a bit more detail about that if you want to as well. But we're not going to be focusing, I'm talking about something more elementary, which is just like, how can it use a tool? The bigger question is, does a model actually use a tool? Let's quickly review our flow. We're here. We load a candidate, we ask it to interpret, and then we ask it to interpret the interpretation with organizational context, right? So we have two stages with model calls. They're both non-deterministic. But the overall flow is deterministic. What do I mean? I mean, when I start this application, stage 1 is going to happen, stage 2 is going to happen, and then stage 3 is going to happen. I can run my program 100 times. It'll be the exact same. Why? The flow is determined by the harness, by my code. It's not determined by the model. The model isn't having any say right now how the code executes. And in fact, for a lot of people, they'll say that this isn't even an agent at all. They'll maybe call it a workflow or an agentic workflow. For them, agent implies that the agent, the model, has a say in how the flow of the program happens, okay? So it's the exact same sequence. And the agent has an ability to affect the path of execution. I want to make it very clear that this is not a bad thing, right? I don't want to run my agent, say, here are 1,000 tools, do whatever you want to do and find evil, right? That's like ultimate freedom. That won't produce any results. What you want is you want to design the detection system. You want to be the architect of that, but create, let's call it nodes or pockets, where the agent has some degrees of freedom to use its reasoning to do what it thinks is one of the better options, right? That's a critical design architectural decision as part of designing a threat hunting system. So exactly what I said there, but I'm not talking about total freedom. It's just that before, let's say, hey, agent, you have to do one, where basically saying like, hey, agent, based on what you decide is the best path forward, you can choose 1, 2, or 3, okay? So I want to introduce you guys to a bigger concept. And if you do any tutorial or anything about agents, you'll learn about this. It's tau loop or react loop. So let's say I have an input prompt. Tau is think, observe, assess, okay? Think. Part of my input prompt is I ask the agent to do something, but I also tell it what tools it has available and how to use those tools. Act is it actually uses one of those tools. And observe is it looks at the outcome of the tool. Then it gets back to think. Now, it's a loop because it can think, I need to run the same tool again, or I'll use one of the other tools, but I'll keep doing that. Obviously, you want to put an upper bound on how many times it can do that. Otherwise, it might just keep spinning forever, right? You'll get a nasty API ball. But they say put an upper limit of, let's say, 5 revolutions. Or it can get to think and say, I've achieved my goal that was set out in the prompt, and I will now produce the output. So what I'm trying to tell you here, just remember again, ACT might include multiple tools. The overall flow here is deterministic, but I'm allowing degrees of freedom within that. I'm allowing the agent's use of multiple potential tools that it can use, decides on, depending on what it decides is the best course of action. The key insight for me here is that the model is never executing tools. The model can't, right? The model is told in the prompt what tools are available and how to call them, usually via JSON instructions, right? The harness will look at the request, and if it decides that the tool call is allowed, the harness is the application running on my system. It can use bash, right? It can execute a function. It can use MCP, etc. So the harness will own the tool process, but the model asks. Another very important thing that I'll just go over quickly is thinking about design in terms of policies and boundaries. So probably if you've used Claude Code, you know that you can run it with #, dangerously skip permissions. I think in Codex it's called YOLO mode or something like that, which just basically means whatever you want to do, including delete everything off my hard drive, go for it. I trust you, bro. There are times in which that's a good idea. It probably goes without saying that there's times that that's not a good idea. If you run it in a sandbox, it actually works really nice. What is the irritating part about not allowing it? Man, you want your agent to do work and it asks you, hey, can I run ls? Can I run cat? Can I run this? Can I run that? And you become so desensitized to it as well that you don't even really look at the request. You just hit enter and then you're like, you might as well be running YOLO mode in anyway, right? But now when you're in the harness, you get to imbue that. So certain commands, you can obviously just allow automatically. Some of them you can allow within context. So don't ask me permission, but you can only run this command if these set of conditions are met. You can run a command, but you need me to manually permit it, or never run RMRF, for example. You're never allowed to do that. Okay. Cool. So let's get to our little lab. Tool use. So this is where we're at. Right now, we're just injecting the candidates, okay? But we're now also going to turn this into a model call, and it's going to be a model call because we're going to tell the agent here, this is a super contrived lab, by the way, but it's really just to prove the principle of calling a tool. So you understand how that works, the logic, and you can extend that, okay? But instead of giving the model the candidate, we basically can tell the model, here is a list of candidates, and here is a tool to retrieve any candidate you would want. What do you want to do? And then the model says, I want to retrieve the candidates. Okay. No shit. I have the candidate right here for you, sir. Come this way. So the outcome of our actual agent is pretty much the same, is that the underlying architecture now changes because we're not forcing the agent to do anything, we're giving them the ability, right? And then in that same request, you might say, for example, here's another tool to request additional information about threat intel or whatever else you want. Or here is a MCP server to Velociraptor if you wanted to get certain information about memory of this host based on what you learn, right? So those are then increasing the options within its tau loop. So in this case, we're just going to give it a function and it can get the beacon data. So like I said, contrived. Here's a job. Here's the tool for the job. And then the model says, I'd like to use the tool for the job. The important thing here, guys, is just the pattern that we're moving away from forcing it, that we're giving the ability for it to request, and then thinking about how to extend that pattern to allow more degrees of freedom if that's something that you do want to allow it, right, at any step. All right, let's run the lab. Oh, system prompts. And one actually very important thing that I should definitely mention is that we are now not asking the model to output natural language. We're asking it to output JSON, right? This matters because if it outputs text, it can change the text a bit. It won't really affect anything. If it outputs JSON, but the JSON is malformed, the application is going to break, right? So whenever you're asking a model to create JSON, you have to have strategies in place to consider the fact that the JSON might be malformed. One way is just to fail gracefully, right? Which is what we're doing in our application. But there are things in Python, it's called Pydantic. In TypeScript, it's called Zod. These are specific libraries for this express purpose. So you can either try and fix it, or you could just send, you can get a error, and you literally send another request to the agent and say, like, you just produced this JSON, and I got this error. Can you just give me good JSON this time, please? And hopefully it'll do it the next time, right? Just wanted to point that out, that it is very important to understand when the output has to be precise versus non-precise, and having strategies in place if you need precise output and it might not be precise, right? Here's the user prompt. Here's the task. Here's the tool, which is just a function in the harness itself. Here's the description of the tool. And here are the arguments. So we only have one tool here now, but imagine there I could put a second or a third or a fourth tool. There I'm telling it all the tools it has available. And I'm going to tell it, here's an example of a JSON shape for the specific tool. Right? So I'm just showing it how to use the tool by way of example. By the way, a bigger meta example is agents are really good at emulating examples. So when I spoke earlier about organizational context and stuff as well, if there are specific things that you like and you want to have them emulate by example, you can always inject that and say, format it like this, or you know, whatever. Let's run our lab. All right, so this isn't a very exciting output because stage 2 and 3 are going to look the same. I just want you to pay attention to this fact that stage 1 returned this, right? It returned a JSON blob, which had the specific tool and arguments that it should use to now go and retrieve the candidates, which is going to be very important for you as you start using skills. I'll point that out, that you give your agents the ability to go get the candidates you want, because otherwise, think about it, guys. If you have many different candidates and many different types of detections that use different combinations, are you going to hard code every single type of candidate it's going to have to get? Are you going to do a switch statement with like 40,000 cases? You're not going to want to do that. You're going to want, give your agent, you're going to empower your agent to get what it needs, right? So again, not super exciting output, but this is kind of what I wanted to point out now, that stage 1 is no longer being injected information. It now goes and gets the information it wants. Right. So I think we're doing pretty good on time. Would you guys like a 5 to 10 minute little breather, stretch the legs, get a drink or something? All right. So it's 20 past 3. Let's break for 10 minutes. We'll come back at 3:30. All right. great skills. I'm really aging myself here. Classic millennial boomer humor. Yes. Oh, yes, you did the Happy Hands Club. Thank you. Yes. Yes, one person. So skills are really the heart. It's such a tight analogy, the heart, right? But the thing that makes this a uniquely threat hunting system and the way you could adapt this harness to be something else is really imbued inside of the skills, right? So we looked at distillation, it gave the agent better inputs. We looked at context engineering, which was give it some more information. And we gave it tools, right? We gave it the ability to do specific things when we decide. But skills actually show the agent how to threat hunt. How do we, how can we set the threat hunt? Remember, we just gave it info and like, yo, tell me if something's going on. But we just assume the model knows how to do that thing. And again, non-deterministically, it might produce different output, might do a different process. We want to control and design that system, right? So first of all, what is a skill? So a lot of you have heard of it when I did my poll earlier. Skills.md markdown file. Anthropic created it, much like they did MCP, but then made it an open standard. So the maintainers of it now are agentskills.io. So when we think about a standard system prompt, right, the user system prompt, we like give it instructions. You are a useful assistant, now do something. A skill, and again, sorry, super terrible cliche analogy or metaphor, but a skill is in some sense a system prompt on steroids, okay? But imagine you had specific prompts you wanted to use, right? And you want to use them over and over. Now, what are you going to do? Are you going to bury them in a switch statement in your program? Are you going to write them all in a file and copy and paste them each time? Really not efficient. There must be a better way to do that. Skills is kind of how do you do that? How do you take these prompts you want to use over and over? And how do you package them in a way that's very convenient to just load them, almost like a cassette that you just put into your music player? Man, I'm getting older every minute. But it's more than that because now, because I've concretized this idea, I can version control it. I can test it, right? I can run evals against it. I can make it reference other skills. I can make it reference specific tools. I can share it with my colleague. Yes. Yes. Yeah, that's just a very poor. It's a very very suboptimal. Yes. Do you mean the entire system in general or specifically skills right now? Okay. Um, well, in general, there is a correlation between your prompts and the quality of output you're going to get. Maybe one day the models are going to be so good that you just say, find bad shit, drop your file, and it like immediately. And all of this is completely superfluous. That might be the case. Right now, that's not the case, right? Depending on the quality of your prompt, the way information is delivered and managed, all that is going to dramatically impact the quality of your output. Yeah. Somebody here had a question. Yes. Yeah. But you know what I love about that though is I love asking these questions because if I thought this question, I would just go, I'm gonna try it and see what happens, you know? So stay curious and don't do a fancy little rain dance if it doesn't really affect the rain coming down, right? So test your assumptions, right? I absolutely love laziness too, dude. Right? The path of least resistance. So this is all about designing a smart system. But remember, right now, this is all about upfront cost and designing this, and then it is also supposed to be designed in a way where it, it will, you're planting an orchard. A lot of work in the beginning, and then hopefully you're going to get more apples every single year, right? After that. So that's kind of the general concept here too. By the way, I'm giving you guys two skills, but I will share more with you guys. They're quite complex. They're very meaty. We can't even go through the entire one, but I would say the best way to learn this system is to look at them and also to just throw one of them to an agent and ask an agent to lead you through this or do my 8-hour course. I'm going to be covering it there. So there's two main problems. Like right now, we don't even control the hunting methodology. Again, we just gave the candidate to the agent and we said, find bad shit, basically, right? But we didn't at all define what the threat hunting process for us looks like. So we want to have the ability to control that process. So we could prompt all of that into the prompt. We can cram all of that into the prompt. But that's a very poor design. And this is just the classic meta design, right? You don't want to hard code every single option. You want to design in a modular way. I showed you guys in the beginning, there are 4 dimensions: initiation, detection, assessment, then narrative. What if I have multiple options for each? Do I want to hard code that into my application each time? Or do I want to have them as unique little discrete files that I can version control, that I can test, that I can evolve, that I can share with my community? Just you would essentially get the same outcome, but it is obviously a much better design, right? Working that way. So really skills are all about, like I said before, concretizing tacit hunting knowledge into executable, composable, testable units. I do want to do a shout out here real quickly for those of you that are kind of in the threat hunting world. There's a guy there called Roberto Rodriguez. A long time ago, probably about, I don't know, maybe 6 to 8 years ago, he tried to do this exact same thing, but using Jupyter notebooks. Threat hunting, one of the big critiques leveled against it is that it's very kind of like airy fairy. It's very like, we have like this thing called the hunter's intuition, dude. Like, how did you know? I just felt it, man. I felt there was something wrong. And obviously, like, organizationalizing that doesn't really work, right? You want your KPIs and all of that. Obviously, you want to see ROI. So, how do we turn threat hunting into a thing that can slot into that system while still not just extinguishing the flame of what makes it uniquely threat hunting, right? So he did that with Jupyter notebooks, but that still needed a human to run them. It was still about creating flows to threat hunting. This is that same idea, but now we're giving it to an agent, and we're like, we don't tell the agent go threat hunt. We tell the agent, here's how you threat hunt. Go threat hunt, and then you have different skills for different types of threat hunts. And it's really the marrow of the entire system is in skills. So I showed this here earlier. I think, yeah, I'm just going to zoom in a bit. So again, these are 4 dimensions. This workshop, we have 4 categories. Each of these will have multiple options. And right now we're going to focus on detection. We're going to focus on one detection skill. That's what we have time for today. And remember, I spoke about candidates, C2 beacon candidate. Each detection skill takes multiple candidates. And exactly how it determines whether there's a threat depends on every single skill. But again, it isn't the skill that I'm giving you guys in the repo. So before, remember, we just took this beacon candidate and we just gave into a prompt, go find it. Now the first thing is we have multiple candidates. TLS anomaly, looking at X509, is it self-signed? Is it a 100-year expiration date? Intel match, right? And that data transfer. Was there a very high ratio of data that went out in bursts, right? Something like that. And instead of a prompt, like I said, now we're going to have a skill. The skill is called hunt C2 over TTPS. So skills I also think of as being atomic. I don't want to say hunt C2 because am I hunting C2 over NTP or HTTPS or DNS? They all differ. The data I want to look at, they all differ. What's the smallest indivisible detection I can compose? That's a skill, right? That's just a design principle. Because otherwise, you're asking it to do too much. You want to paint a very precise target and tell it to go for that, right? So this is lab 6, skill learner and detection skill. So let's recap where we are. If you guys can remember, we have a tool here. It loads a candidate, sends it here. It does a detection, sends it here. It adds an assessment on top of that detection by also giving it organizational context. So we're going to drop stage 3. We're going to bring it back next time just to kind of simplify things a bit. So the main goal for this is to go from, hey, can you detect bad stuff from this one candidate to go fetch all these candidates, see if there's a bad thing. This is the bad thing I want you to look for, C2 over HTTPS. And this is the exact process you're going to follow to do that. So on the highest level, a skill has two things. It has YAML front matter, that's just metadata, that just describe what is the tool, how does it work, all that. And then it has in the markdown the instructions, okay? I'm mentioning this because these two parts are actually going to be consumed by two different stages. Stage 1 will load the skill, parse the YAML from the markdown, and it is going to inject the YAML. Why? Because the YAML says what candidates to go and fetch. Okay, so it uses the YAML. Harness loads it. Harness reads the metadata. And just to show you, this is the metadata. This is the YAML, and there you can see the beacon is the primary, meaning that is the first thing it looks for, and then it sees for this connection, do I have an associated candidate in TLS, Intel match, and data transfer, right? Then it uses the tool, it goes and fetches the 4 candidates in this case that it needs, and it bundles this into a full evidence bundle, and it gives that. Before, remember, it just gave one candidate, now it just gives all the candidates. But again, maybe I can just point out, think about it. It got these 4 candidates. Why? Because that what was stated in the skill. But now if I loaded a different skill, it'll just go look what are the candidates that other skill needs and then go and loads those. Right. So that's where you create the modular flexibility, right? Stage 2 is interpreting the candidate. So now it's going to the skill was parsed in memory. The body is there. The body has the instructions. So it now receives the evidence bundle, and it also has the instructions from the body. It's going to output the findings to stage 2 analysis. This system prompt, we can see we have the wrapper instructions and the loaded skill body. Then here we have the task instructions and the evidence bundle that was received there. Sorry, I don't know if I'm going through it a little bit quickly now, but was all that kind of clear for you guys conceptually? Yeah. Same basic system. Again, instead of just hard coding and simplifying things, we're introducing a skill-based system now. All right. You can see already there, it got 4 candidates. Got its evidence bundles. That's now being sent to the second stage for the detection. Any jokes? Anyone? Any volunteers? Yeah, I have a joke, but I'll save it for the next one. Classic dad joke. I hope you. Yeah, but it's gonna come in the next one. So we're done here. Okay. Obviously, there's a lot going on here, guys. I can't really work through all of this now. It's going to be a little bit awkward. Obviously, something I would consider about adding as well is just some prettifying to the terminal output, right? But you can see all the different results. Maybe we could just see let's look at the reasoning chain. Primary C2 signal is strong from the beacon dimension. That's the beacon candidate, right? TLS anomaly evidence, this is another candidate, independently supports suspicion because the destination presented a self-signed, naughty, naughty, expired 5-day certificate. Oh my God, bro. Script kiddie, am I right? No SNI and raw IP HTTPS usage. Like everything it could have done wrong, it did wrong, obviously. So here as well, Intel flagged it as a Cobalt Strike team server. Oh, the intermatch does not match it. Interesting. The same process also conducted high volume output HTTPS transfer to a different destination during the beacon window, which materially raises concern, but is kept separate as a related activity rather than folded into the C2 endpoint score. Does that make sense to you guys? Kind of what happened, what we're looking at here? So we defined much more clearly our process of finding threats, and we now have 4 different candidates that were like woven together as an atomic detection bundle, which I call C2 over HTTPS. Okay. Okay, we're getting there, guys. It's 2 more labs, and then that's that. So we're just building on this now. We just had our detection skill, and now the next one is assessment skill. We already had assessment before, right? All we did was kind of add our organizational context, but we want to skillify this section as well so that we could have different ways of assessments. And in the same way, have a modular design where we can load different markdowns for it. It's going to be very, very similar as before. It's just that we're imbuing that design pattern here to have that ability, all right? So let's recap where we are. This is what we just looked at. So we'll add stage 3 back. And just to simplify this, I'm going to remove this, but it's still there, right? I need some real estate to show you guys. So now we have our 3 stages. We just looked at stage 2 analysis. Now we're passing that to stage 3. So before in stage 3, the specific assessment we did, it was hard-coded. It was in the prompt. So it was in the system prompt. We gave it organizational context, but maybe sometimes, well, what was your name again? No, you. Colin, yeah. So Colin pointed out earlier, like, well, what if your organizational context is huge? What if you just fill up the whole window each time? Well, maybe you want different slices of organizational context. You want it to look at this specific aspect or this specific aspect. How are you going to do that? You're going to do that with a skills-based system. You have to have different skills for them and then decide which skill to load, right? It's for the exact same reasons. So again, it's going to just go and load from skills, and then it's going to go fetch from organizational context. It's going to output now to state 3 analysis. That's it. All right. You guys ready for my dad joke? At least promise, at least one person will laugh. Thank you. A bear walks into a bar and he sits down and he says, I would like a rum and Coke. And the barman says, why the long pause? Bears? Oh, I screwed it up. Fuck, it's why the big pause? You had one job, dude. What the hell? Okay. I'll come better prepared next time, I guess. One with a horse and a long face. Similar. You have it? Yes. Doesn't it involve a horse with a long face? Yes, great question. Well, you obviously need to keep track. So they all have their unique ID numbers, right? So you obviously have to have a system that has a memory of what did it already look at and make sure it doesn't look at those same ones, right? Does that make sense to you? So the human wouldn't review at that point. That would all be automated. Um, Let me show you. Okay, so I'm gonna get back to you. I'll just show you guys kind of the outputs. The output is really extremely similar to before. We just had the detection finding right now, and all we did now, guys, was add assessment, a skill-based system. So it's just kind of like more precise and more formatted according to our design, right? But the information is still pretty much the same. Okay. So yeah, I'm just gonna finish answering his question, then I'll happy to get to you. So great question. I feel like philosophically almost it's one of the primary conundrums at the heart of this system. It's also why, guys, I think threat hunting is about 10 to 15 years old. Um, I don't want to say it's a response directly to alert-based security, but it is trying to solve one of the problems with alert-based security, right? Assumed compromise means we believe alert-based security is always going to fail to some extent, and there will always be threats inside of your network. So philosophically, why don't we assume compromise and we go and find those threats, right? Threat hunting, I think, by design and by architecture is really good. And depending, obviously, on the quality of the threat hunter, can work really well. The major problem with threat hunting is its inability to scale. And that's why, even about 10 to 15 years into the discipline, it's really seen as a luxury for big companies with a lot of money. Smaller companies will sometimes say, like, to their security analysts, maybe a security analyst are like, boss, I really want to threat hunt. They're like, okay, every third Friday you can hunt for the day or something like that. But it's always been an afterthought. And the primary reason is you'd rather have people would rather have mediocre defense over like 90 or 100% than really good. I'm just making numbers up, by the way, over like 10 or 20%. And that's threat hunting's problem. The human review could never scale, right? One of the things that I think is the amazing opportunity that integrating agents into the workflow is it allows the human to massively scale. Because nothing what I'm doing here, think about the skill system. I created that based on how I would threat hunt a skill. So it's an extension of what I'm doing. The important thing about you as a designer in creating the harness is understanding when should it alert you and what severity when at the final points you could add hooks into Slack and say if a certain threat reaches a certain score, only then alert me, otherwise just archive it, and I can always go and look at the ones that you decided weren't threats, and maybe I'll see there that, oh my god, this should have been a threat. I need to tune the sensitivity of my parameters a little bit to allow that next time, right? But at the end of the day, maybe I'll just go back to this slide I shared at the start. In the system I am designing, really that little dude from the 50s there, honey, I'm home, that dude, that's really where the human gets involved in the process, right? There's another tired analogy. I love my tired analogies, which is a flywheel, right? Flywheel is like one of these big wheels. And the whole thing there is in the beginning, it's maximum effort when you need to get it to move. But because it has weight, it creates its own momentum. And the idea is the most effort is at the start. And as it starts turning, it's less and less effort required from you. Right? A system like this would be the same, right? Because in the beginning, you need to tune it and you need to make sure it is a reflection of your process and things you find should be alerted on, are alerted on or not. But the hope is then the investment in your energy will lead to less and less involvement on your parts, right? Man, I kind of went all over the place. Did that kind of answer you a little bit there? Okay, cool. Yes, question at the back. Yes. Yeah. Yeah. Super relevant, bro. Really. Yeah. Yeah. So sorry. It's very relevant. I think, it was one of the seven system feedback and evals, right? But it was one of, I just had, I could either like skim through everything today and like rush through it, which is hard because then nothing really makes sense, or I can choose a few things to kind of get into a little bit meatier. So skills is really where I spent most of the time because that's kind of where we think about what threat hunting is, so sorry to disappoint you on that front, but yeah, I would be able to get into that in the 8-hour course. But yeah, that's not really covered today in real depth. Sorry. Oh, thanks for asking. All right, final lab. Who's got the dad joke? You guys. What is that old saying? It's an old Romanian saying. I think it says like, "Never go to a computer security conference without a dad joke." You guys heard that one? You all failed today. I guess I failed too because I couldn't even get the fucking punchline right. That's insane, dude. Such a difficult joke. All right, let's do it, guys. So I want to just quickly, this is kind of the crescendo, guys, the climax, if you like. And so I just want to kind of rebuild the complete picture for us here. So just forget about this little thing. We have a LM call now at every stage. It's just implied. All right. Again, I just need the real estate. Each state is going to call the model. So the first one, like we saw, it's going to load the detection skill. It's going to parse it. It's going to use the YAML to know which candidates to load. And it's going to go load those candidates, and it's going to bundle them together as state one inputs. So we have this is stage one. It goes to skill. It loads it into memory. It takes the YAML. It knows what to go load. It goes and loads that. It's going to output that. Stage two, we already kind of saw this. This is our detection, right? It's going to read the markdown body, and the markdown body is the exact instructions of how to threat hunt. It's going to call the model. It's going to pass the instructions. Here's how I want you to threat hunt. Here's how you do threat hunt. Here's the evidence bundle. It's going to output its finding to state two analysis. So obviously it also goes and gets the instructions there, outputs it there. And then stage three performs assessment analysis. That's what we just did. Kind of harness reads a new skill, also reads the instructions, but this time it's not about detection, it's about assessment. Assessment for me means, in the light of this context, what extra thing can you tell me? All right. So model instructions, organizational context, and it consumes the analysis from state two, and it's going to output the findings to state three analysis. So it's going to go there, it's going to load organizational context, because in this example, that's the skill we have. It outputs state three analysis. So this is just a recap. This is where we are now. What happens now? Our final stage. Weave narrative. This is what I call the narrative skill. Because think about it. If you find something that's a C2 communication, but you also find some process injection and you find some funky SMB communication that could indicate lateral movement, what you are looking at is different fragments of the same campaign, the same compromise, right? So you want an agent to be able to potentially zoom out and see the bigger picture here, right? That's the idea of the narrative agent, putting the different dimensions together. So it also has a report template, and it's going to produce the final report. And then in our simulated world, this is now what's being consumed by the human if they're notified that, hey, there's something I think you should take a look at here, right? So let's just review this graph quickly. This is what we have now. But I just told you the entire purpose of narrative is to weave different assessments together. It's its raison d'être. I like my French, guys. But we only have one track. I only had time to cover C2 over HTTPS with you guys. And so I'm just going to give you the output of another skill, which looks at a coding agent that was prompt injected and downloaded and injected payload into memory. and started the C2 beacon. Right? It's kind of the initial access part of the MITRE attack chain here. So I'm just going to give you that. And again, it's as if this entire thing happened and produced this here. I should have actually just run it there, I guess. There. And so now weave narrative is going to consume two parallel tracks. And I have to give you that because otherwise there's no point in having a narrative, right? Does that make sense to everyone here? Right? Just like a detection skill consumes multiple candidates, a narrative skill consumes multiple assessment skills, basically. Detection plus assessment skills. Yeah. So integration. Let's go look for the common narrative. That's going to finalize the report. So let's run it. Yes. Yes. Couldn't agree more. I actually believe it is part of it. Let's quickly. So this is the final. Just actually want to. I'm still answering your question here. I didn't do it surprisingly because I do want to state that I think there's always a danger to kind of get lost in frameworks and stuff, but MITRE for me as a threat hunter too is huge. And it's also very, very good because it helps me really understand where and where not to spend my energy and attention based on how huntable it is, basically. Okay. But yeah, thanks for pointing that out. That's a great insight, and you are right on the money here. All right, guys, so here is the final kind of narrative. So I'm not going to go through everything, but now think about it, right? We have this kind of C2 over HTTPS beacon finding. Now it also got a sketchy process that was related to that. I already told you we can connect connection 3 tuple to process con.log sysmon event ID3 sysmon event ID1. So we can make a connection there, right? So it says this is a high severity incident involving likely HTTPS command and control. Oh, what just happened? Oh, it overwrote. Okay. This is the old one. Okay. Likely here, the strongest evidence was 60-second. Okay. So here it is. It is not. Why do I not see? Okay. So here it has information. So here, earlier execution code.exe to PowerShell.exe. Okay. So for example, that now came from the assessment finding related to the what I call AI agent anomaly, which is just kind of like it's an atomic version of kind of like bad parent lineage, all right? So it just looks at the relationship between a parent process and it's the child process it spawned, okay? But the final thing is really the report. So again, it's everything woven together. And then we have all our audit trail here and uncertainty and open questions. And that is really where I wanted to get with you guys today. So I have like 2 minutes just to wrap it up. Some of you are hunkering for more, but before I get to that, is there any questions specific to this final lab output? Even if it's just questions or statements, observations, anything. Yes. For sure. Yeah. It's a very good thing you're pointing out here. When I design like a workshop like this is kind of what's called the happy path, right, guys? So I'm kind of showing everything happened perfectly and I knew and everything fell into place. But most security isn't going to work like that at all, right? So you have to have an anchoring skill that it only makes sense to find other skills related to that. But the whole way to connect them with each other happens with a knowledge graph. I'm still working on fully building that part out. But the way to synthesize enough skill output and see whether or not there's connections between them, because it could also just happen that it looked at the top process and the top C2, maybe they're both actual compromises but have nothing to do with each other. Or maybe one doesn't have to do with each other or something like that, right? That is where knowledge graphs comes in to compress enough, I would say, pertinent information that can be connected and linked to each other to find the connections there. But I would also say in terms of the design of the system, that would be the biggest, I think, the biggest challenge. I haven't fully clarified that to myself either, but definitely thinking like an engineer there. Good job, dude. Yeah. Question over here. Sir. Good sir. Do you have a question? Oh. Oh, you just waved. Okay. Just happy to see me. Yeah. Yes. Mm. Mm. Yeah. Cool. Yeah. No. No. Yeah, absolutely. I guess one of the more kind of like fundamental questions here too is I don't want to like peel the onion all the way back, but like, are we going to be out of, are humans not going to be necessary because AI is just going to be able to do everything? And there is so much layering and revision and guidance that has to come into even creating a system like this. But I mean, I don't know. I'm obviously not like a seer. I don't know, 10 or 20 years into the future, but it's, you know, as you kind of, I think, correctly articulated, this is only as good as the person that designed it, right? The models didn't really come baked with any of that. And there were certainly a lot of places. Like my strongest aspect is like threat hunting network behavioral telemetry. And I can tell you so much of that it originally proposed was just like completely whack, dude. Like it had absolutely, yeah, no idea what it was talking about. And I also understand it because it's a very niche field and it wasn't trained on a lot of data, right? I had this conversation with somebody last night, but you know, a model, even the best models, they're only as good as the amount of data that were trained on something. So they are, for example, extremely good at writing JavaScript or TypeScript. Why? It's probably the most predominant language out there. They've been trained on libraries of Alexandria's full of TypeScript, right? I kind of got into, so I'm really into Zeek, which is basically a detection engine for network telemetry. And it's fully scriptable, and it also has its own protocol parsing language called Spicy. Now, guys, Spicy, like there's one dude on YouTube that teaches Spicy. And if you want to learn Spicy, you have the docs pretty much. It's not like this thriving community and ecosystem. Like you go read the docs and you go maybe check this one, do a few examples, and then figure it out, right? I tried to get the LM, and I mean, this was maybe like Opus 4.5. It was somewhere last year, but it couldn't write compilable Spicy at all, even though it was really good developing. I was developing fairly sophisticated C2 framework in Golang, which is also really good at. It couldn't do any kind of Spicy. So if you think about extreme forms of niche information related to threat hunting or whatever, then yeah, absolutely. It's not just gonna, you're not gonna press a button like make ultimate threat hunting network now. Yeah, come back later. Right. So guys, just to kind of wrap this up and say goodbye to you guys. Conclusion. I just gotta like do a little plug. If you guys are into what I said today and you guys want to learn more, I'm doing a 1 hour talk online. This is all with Anti-Siphon Training, is the company that I work for. So you can just search anti. Yes. Well, that would be part of the maturation process of it. Yeah, but a big part of that would be creating different sets of telemetry in which you know there to be threats and seeing if it can find us, right? So you have to have like you can call them calibration data sets, right? If you think of like a scientific theory, it's kind of like your null hypothesis, right? Will it find the things in that? So, well, you either, there's multiple options. Either you have access to real telemetry, which you can disguise, if it's client telemetry or something like that. You can create various degrees of synthetic telemetry, right? Or you can simulate it. And that's kind of like the spectrum from real to created. Yeah. But yeah, great question. Yes. So these are all Zeek and Sysmon events that I run a simulation on. Yeah, and then code it synthetically because it's on my own network. So I just substituted specific information. Yeah. So that was the original input. And then what you guys got here was the output of the distillation process. So it's also, I just haven't wrapped my head around how much of the distillation process I want to share, but it's not like I'm building a product to sell or whatever. I just need to kind of clarify, like make sure I make a real intentional decision once I release it, but I'm probably just going to release all of that too. Right. I'm doing a 4-hour workshop at the 12th of June and then an 8-hour workshop on the 26th of June. It's $295 though, just so you guys are aware. If you guys want to learn more, here are some of the resources I can suggest. Here are 3 guys on Twitter. The main thing is almost all the resources about harness engineering is for developers. And there's very, very few security people showing how to do it for security. But you can learn a lot of things there and then apply it yourself to security specifically, right? I think deep learning at AI, it's pretty good too. They have a lot of like courses come up. Most of them are free. And then I find the AI engineer talks on the top right too. It's pretty good too, right? Just don't get too obsessed with watching talks. There's a Richard Feynman quote, what I cannot build, I cannot understand, or something like that, right? So you're going to learn this stuff by building it yourself. And then on the bottom right, I'll just quickly show you guys. It's a platform that I'm launching. This is just the local dev version right now. Hope it works. Worked earlier. Yeah. Okay. So I have courses, and then again, I don't want to like plug myself too much, but just so you guys are aware, this is launching on the 26th of May. And so we have an academy here. It's really a training platform. To basically put it into the simplest terms, it's like try hack me or hack the box, but specifically for learning harness engineering for defensive security. So we have a whole bunch of like self-guided academy modules here. I put a lot of energy and effort into making nice graphs, and then you have questions, etc. I have a whole interactive library of threat reports. I have courses that'll come, and then labs are all about. So, for example, let's say you wanted to learn one specific candidate. There's a room that will teach you all about that. So there's a little story I create about it. There's a fundamentals lesson all about that. And then you can essentially launch a simulated environment that is going to give you the intel. It is going to show you a topology. This is the very simple one because it's kind of a tutorial one. You can go look at all the specific events related to everything. And then here are the candidates. So again, the whole point of this one is just to give you exposure to what a beacon candidate looks like. And then everything it kind of like teaches you as well. So that if you don't know what anything means, like for example, it got this score, here are the components, but it'll tell you exactly how that was calculated, what kind of statistics and stuff. So it's really like an interactive, and I try to be as visual as possible way to teach you a lot of the concepts. It's not things that are necessarily unique to my system per se, but I think are foundational ideas related to threat hunting in general. All right. Final slide. Thanks. So that's my company, IronSec.ai. If you wanted to sign up there, I'll just let you know when I launch. I'm not going to spam you. I don't do any of that crap, I promise. But I'll launch on the 26th. You're going to connect with me on LinkedIn, on X, YouTube, or on GitHub. That's me. Cool. Thank you. Also happy to hang out if other people had more questions, or if you want to sit here and hang out with me here and ask, all good.